So I'm Leah, and I worked with Ananya this summer, and I really had a great time working with her on her project. And coming in, Ananya already knew so much about programming. She knew how to code not only in one programming language, but several. And she really hit the ground running, initially presenting 8 different ideas for what we can build, of which she ultimately chose one using facial recognition. And although, we hit several roadblocks along the way, as can be expected, Ananya really, persisted throughout and did all of the necessary research, diving deep to figure out what we needed in order to proceed. It was clear that Ananya was driven not only to build something that I think is really cool, but also to really understand in depth exactly what it is that we were doing, what was the code doing, just understanding everything that we were trying to do. And she did all this despite a lot of competing responsibilities in the summer, including her SAT prep and college applications, as well as holding a technical internship. So overall, I really enjoyed getting to know Ananya, and my favorite part was just working with her to tackle a problem, try to break it down, and peer programming together, and having a lot of fun doing it throughout the process. So with all that, welcome, Ananya.
Hi, I'm Ananya Krishnan. I'm currently a 12th grader at Nikola Tesla STEM High School in Redmond, Washington. My mentor for this, my slide's not changing. Okay. My mentor for this project is Leah Einhorn. Leah is a lead software engineer at Kepler Group in New York City. She comes from upstate New York and loves to run and read in her free time. Working with Leah has been magical, to say the least. I am incredibly grateful to have been assigned a mentor from whom I can learn so much from during my project and outside my project as well. My project is called What a Blur, and fittingly so. My goal with this is to be able to perform facial detection and facial recognition with machine learning. What my project is essentially is a machine learning algorithm that detects a face and uses feature extraction to recognize that face when it is shown in an image with other faces in the image along with the detected face. All the other faces are then blurred. The biggest reason I chose to work on this particular project was because I find artificial intelligence to be very intriguing. I find it to be a very intriguing aspect of computer science to look into and work with. I thought it would be amazing to learn to apply machine learning to a project that could end up having real world applications one day. I'm still in awe of how many new skills and how much knowledge I was able to gain from working on just one project. The first thing I had the opportunity to learn about more was machine learning, which is basically the method of data analysis that automates analytical model building. It is a branch of AI based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. I got to do research on situations in the real world where this type of AI is applied and what kind of effects it has on the human population. It was absolutely eye-opening to see how much of our world depends and functions off of the working of AI. Furthermore, I learned about how the Python programming language is used with ML specifically, since I've worked minimally with the language before, but I've never worked with a situation in which AI is involved. Along with just the syntax of the language, I learned about a couple of new Python libraries that I had not worked with or heard of too much prior to this project. Two of these, for example, are NumPy and OpenCV. I ended up not using NumPy towards the end of my project, but I'm so glad I got to learn more about what it is and its functionalities. OpenCV, however, was the backbone of my project. The library aided me in everything from the initial face detection to finally the recognition and blurring stage. In addition to the libraries, I learned more about how to do proper research, digging deep to compile only the most relevant, useful resources. Good research was especially important during the initial stages of my project when I was learning more about the process of facial recognition and identifying exactly what my input, output, training data, final data, and libraries would be. I did my project using the Google Colab notebook and understood its working significantly better by the time I finished my project. I had done another project for a science fair earlier this year using this environment, but this time I learned so much more about what kind of imports I can make, what's flexible in the environment, and what kind of settings I can adjust so my work is more understandable for the user as well as me, and what makes it easier to debug as well. While finishing up my project, I got to become more familiar with GitHub. I referred to work on GitHub throughout my project so I could draw from the experience and work of those who attempted projects similar to mine. The platform was abundantly helpful. I learned how to upload files, look at deleted commits, and how repositories work. So how exactly does my algorithm work? The user will have to insert the image path of both the training image as well as the final image into the code segment. The training image will have to be of just one individual, while the final image will be of that individual with other people. Once the user does this, the algorithm will load both images so the user can double check and make sure that those are the images they intended to insert. It will then detect the faces in both images. When the detection is complete, the algorithm will use feature extraction and detection to match the face of the individual in the training image to their face in the final image, that is, the group picture, putting a box around the recognized face. One thing to note here is that I did not have to explicitly code the feature extraction because the library I used enabled that to happen as part of the statements I put in for the recognition to take place. Now that the recognition is complete, the algorithm will blur out all the other faces that did not match that of the training image or the individual picture. There we have it. The facial recognition is complete. Shown in this image is the screenshot of my algorithm detecting 128 distinct features of my face in the training image, as I mentioned previously, so that it could perform the recognition in the final image. We as humans only see the images as faces, while the machine reads it as a set of numbers indicating features and dimensions. At this point, I would like to talk a little bit more about my research process, as well as some of the highlights of my process while putting the project together. As I mentioned earlier, keeping my research very focused, relevant, and deep was important. I wanted to understand the application of artificial intelligence thoroughly. So some questions I asked through the research process were, what libraries will be more flexible and compatible with Google Colab? How many inputs will the user have to make in this algorithm? What is the process by which I want my algorithm to perform the facial recognition? To answer all these questions and more, I took time to look deep into the topic with the help of my mentor, of course, and collected the resources that I thought were best. To keep me organized, Leah and I put together a shared resources document which we could refer to at any point in our project. For me personally, I would say that one of the major highlights of my process was learning how to debug properly in this particular environment. The best part about Google Colab is that when you run into an error, it explains to you not only where the error is occurring, but it also provides links to sites such as Stack Overflow that may give you the solution to debug your error. As a beginner in ML, this was immensely helpful to me. I also learned that it's super important to increment your code and make print statements every now and then so that I can know exactly when my error is occurring in that specific point in time. And in the case of the error, I want to know which specific line or statement is causing it. The image to the right is a screenshot of me printing the results of the facial recognition cell so I could see why my program was initially matching the wrong face. Printing the results in the middle helped me note which order my algorithm was looking at the faces in and where it was marking the wrong true, where it should have been marking false for the match. This demo will show the results of running the two most important cells in my program. The first one shown there being the cell that loads the training and final data. This one's labeled training. So this is an individual picture of just me. And the one below that is the final image, which is me in a group. The second cell being the cell that iterates through every face in the final image to match the face in the training image, and it finally performs blurring on the faces that were not recognized. And as we go down, we see that it has matched my face accurately and blurred everybody else's face out. The ultimate goal with this project in the future is to be able to implement it in videos for practical situations in the real world. The situation that I had in mind when I chose this project, the situation that inspired me kind of, was making use of the algorithm on a CCTV footage. If the police are looking for a robber who they happen to have a mugshot of, for instance, and they look at a CCTV footage of the bank he robbed last week, the algorithm can be implemented to scan an individual picture of the suspect and identify that face in the footage. A square will be put around the suspect's face if they are in the footage, and every other face will be blurred. This will aid the police greatly in increasing their precision and observing the actions of the suspect in the footage. Hopefully, I can continue working on this project and develop to this point. The implementation of this may not necessarily just end, or it's not limited by just a CCTV footage. I hope to implement it in other videos as well to increase precision, seeing as that is one of AI's most, it's one of AI's most major functions, to increase precision. Magic has been one of the most memorable experiences of my time in high school. For that, I will start off by thanking my mentor, Leah. I found it amazing that we could discuss not only anything concerning our project, but also activities outside the project in our lives, such as Leah's professional experiences, my extracurriculars, and internships, etc. I was able to find a connection between aspects of my project and my everyday life instead of viewing it as just some summer work. I also learned so much more about the workings of Python because Leah always took the time to sit down and explain everything to me and answer the many, many questions I would ask her, no matter how long it took, whether it be 1 hour, 2 hours, etc. That dedication made my experience that much more meaningful. I learned to persevere through my project as well. Debugging errors and digging for helpful sources that would fix the errors definitely got frustrating at times because it would be extremely time consuming and I wanted to make progress. But I learned to persist and take the time to understand. This made the moment that much sweeter when my algorithm finally worked. That concludes my presentation. Thank you all for your time, and thank you, Leah, for mentoring me. Any questions?
We have time for one question.
That was awesome, Ananya. This is, oh, I see Nikita has a question. I can let Nikita go.
You can go first.
I think we have time for one, so I'll
Wait,
let
okay,
the
quickly.
mentee go.
Just ask.
Okay. My question was if you had any, it was really cool, and I was wondering if you had anything that surprised you while you were working in AI and ML. So
I actually thought something that surprised me is how similar it is to like the coding that I've done like in high school, just like small projects. I always thought of AI and ML as something intimidating, something that's like inaccessible to me almost. But as I was working through this, I realized that, hey, it's pretty much the same debugging process where you increment it, you learn from it. And for me, Python was actually not something I worked with too much before this. So I was learning on the go. And when I was doing that, I realized that this is pretty much the same as I would do for Java or something like that. So I realized that it's very accessible, not just to me, but for, people everywhere, beginners. It's so accessible and it's so fun to create and use when you have a project in mind.
Nikita.
awesome. Thanks.
Your project looked really cool and I thought it was really interesting. And I was wondering why you picked it over your other ideas that Leah was mentioning.
So the biggest deciding factor for me was how applicable it is in the real world. And also, of course, how interesting to me it is. I spent the greater part of my childhood watching like CSI Miami. So, aiding something that would help in the CCTV footage was so appealing to me. And I thought that it was definitely something that is a practical application. It aids a lot in precision. For now, I feel like it's always like a struggle when you see someone in the CCTV footage, you see them moving along with, 100 other subjects. But when you can blur all of them out and, have a box around this one face, it's that much easier to, see what they're doing and identify them as your suspect accurately.
Thank you, Ananya. Congrats. Awesome work. We will